Now the next example, a hollow steel tube, okay, 3.5 meter long, has an external diameter of 120 millimeter. The external diameter is 120. Now, in order to find the internal diameter, so that means you have to find the internal diameter, okay? The tube was subjected to a tensile load of 400 kilonewton, okay? And an extension, I think an extension was measured to be 2 millimeter. So that means the changes in length is 2 millimeter, delta L. Now, if the modulus of elasticity for the tube material is 200 gigapascal, find the internal diameter of the tube. So you have to find the internal diameter of the tube. The external diameter is given. So this is the tube, okay? So they did give you the length of 3 meter long, okay? It should be longer, but then I've shortened it, okay? This is called a tube. You can see it is very thin wall. It's with a very thin wall, so we can call it as a tube. Now in the cross-sectional area of the tube, so you can use this formula here, but remember you don't know the DI yet, okay? So you can substitute the 120, you can remain as everything in millimeter first, okay? Up to you. Okay, why millimeter this time? Because we don't want to have a lot of decimal places here, because since this is unknown, okay, it is better for us to remain it as millimeter. This is a tactic, okay? So you have got your area formula is this. In terms of DI square, this is DI square, actually DI. Okay, so you got your A in terms of this. Okay, the extension of the tube. Now, we form the first equation first. So, and the second equation, this is actually the two formulas. One is the Young's modulus, the other one is the stress formula. So the third one is the strain formula, which gives you the delta L over original L. Substitute 2 and 3 into 1. Substitute this equation here and this equation here into the first equation. That means your stress, force over area, put it here. Your strain equals to X or delta L, up to you. You want to use the symbol X is better, okay, over L. So put it here, okay? So you will get something like this. So when you substitute this into here, okay, and this into here, you got something like this. E will be equals to FL over A times delta L, if you put the E on top first, subject. So you can always move your E subject changing to the subject as delta L, okay? Why we change it to delta L to be the subject? Because they have given us an extension of 2 millimeter. We are going to make use of this value here. So remember, you have something in meter, you have something in millimeter, yeah? So, and then you can also, okay, put a subject as A, okay? Since you want to find internal diameter, so better change the subject to A, okay? You can keep this step actually, okay? By writing E equals to FL over A times delta L. E, put it here. Then you can change this to A to be your subject, okay? Area to be your subject, because that is where your unknown is. That is where your unknown is. So it's better for you to change your A to be the subject. So put in everything into this formula. Put in everything, including this. Or if you want to find in terms of A first, you can do so. My advice is find everything in terms of A first. You get A equals to something. Then only equate to this equation to find out the internal diameter. Okay? So you will finally reach to this step here, where you can find the diameter is 99.71 mm, or maybe is slightly bigger or slightly smaller. It doesn't matter. Okay, maybe it's 100 or maybe it's 98. That will do. okay, or 99 that will do. It depends on your decimal places. Okay, so that's all for today. That's all for today.